developer, and I'm here to talk to you about something a little different this week, this month rather, called OpenCyc. I had the interesting experience of working on this project a few years back. I haven't worked with them for a few years, so I don't take anything I'm saying as speaking for anybody at cyclop, or that anything I say is gospel. But I want to talk to you a little bit about this AI project because it's interesting and something different, but also because you can, for free, use the most important and useful part of it, and I'm going to show you a little bit about how to do that. So if you're at all interested in something weird or different in the way of AI, or if you're doing anything where you're classifying things or processing natural language and trying to do that a little better, then I may show you something that you may even be able to turn into something useful. I'm going to start with a little story about 2 years, and that's... Come on. It's a little slow because psych is starting up in the background. So the 2 years I'm going to talk about are 1967 to 1984. 1967 was a great year, I think. Apart from the whole Vietnam War thing. But this is what the music looked like. This is what art looked like. Okay, that's what cars looked like. And that's what a computer looked like. And this is what AI looked like. This was 16 years after the first UNIVAC, first ever commercial computer, was installed. And in that time, people had developed computer programs that could play chess better than almost anyone in the world, that could prove mathematical theorems, that could engage in natural language conversation to some extent. It seemed as though that so much progress had been made in that limited amount of time that Marvin Minsky, probably the most famous AI researcher in the world, thought that within a generation, before now, we'd have Howe, right? So fast forward another 17 years and we get to 1984, and that's what music looked like. And psych uses a lot of resources. That's what art looked like. I defy anyone to find an iconic piece of art from 1984 that isn't like an album cover or something. That's what cars looked like, computers. And in 1984 at AAAI, which is the annual far and away the most important artificial intelligence conference in the world, Marvin Minsky engaged in a debate that was titled AI Winter. It was the first time this term had been used in public. And Marvin Minsky, during this debate, warned everyone that AI had been massively overhyped, was failing to deliver on its promises, and that great disillusionment would follow. And he was dead right. Within 2 or 3 years, all the Lisp machine companies had all folded or were in deep trouble. And research funding, and particularly commercial funding for AI, was drying up all over the place. And the reason was that his initial optimism about AI was just wrong. It was just very, very wrong. It turned out that while computers could do things that we found hard, making computers do things that we think is really easy turns out to be very, very difficult. 1984 was also the year that the Psych project started. So the Psych project was founded by a computer science researcher called Douglas Lennart. And his opinion was that he didn't know everything you needed for AI necessarily, but before you could have AI, you would need to have in a computer a very large amount of prosaic, everyday facts about the world. So if you get a computer and you feed it the sentence, Jack and Jill went up the hill, and then you try to ask it any questions about that, there is so much that's implicit in that even a 2 or 3 year old will be able to tell you why they were going up the hill and who and what Jack and Jill were and what a hill was and what a pail was. The computer has none of that information, and until that kind of stuff was in a computer in some rigorous form that the computer could access, you'd never have AI. And he thought, he said 2 years after the project started that he thought it would take about 250,000 facts being placed into the computer in this way, and about 350 man-years of work. And we're at about that point now. And he thought once you had that in the computer, that you would then be able to write software that could take in ordinary text and use that to expand the common sense knowledge base automatically after that. And that then you would have the foundation on which you could try to build AI. So that's where Psych is at now, is that we have a very large, what's known as an ontology. That's a formal representation, a formal language for stating facts about a domain. And in Psych, the ontology is designed to allow you to state facts about anything and everything. It's a little hard to see in this slide. I couldn't find a higher resolution version of this. But if you look at the hierarchy, it starts sort of with thing at the top, and it goes down through various sort of abstract concepts of time and space. It has things about sentient beings and social behavior and human activities, and there's politics and war in there, and there's everything. This is kind of a hierarchy that over the 25 years that this project has been going has developed as a way of representing anything and everything. And what I want to do is talk to you about a particular part of Psych. Psych consists of, first, this ontology, this set of concepts that you can use for talking about things, and vocabulary you can use for talking about things. And then there's a large set of rules that allow Psych to decide that if you put water in a bucket and you hold it upright, then the water will stay there. But if you tip it over, the water will come out, or what you need to do if you want to go through a locked door, or whatever. You can get hold of the full Psych if you contact Psycorp and ask them nicely. They could give you a license for research Psych to use for non-commercial purposes, and that pretty much gives you the whole thing. But you can also download Psych from OpenCyc from SourceForge. And OpenCyc is basically the entire set of concepts, but none of the rules. So what this is, I think crucially for anybody who's interested in classifying things or working with natural language, the world's largest well-organized ontology. When you fire up Psych, this is what you see at the end of the terminal window that's probably still running behind here. There is in Psych something like 150,000 constants and 1.5 million assertions about them. So there's somewhere between, probably somewhere between Doug Lennett's 350 man-years and maybe as much as 1,000 man-years of work has gone into putting all this stuff together. So the intent is that it should be encyclopedic. That's why we have the name. And it certainly doesn't have everything in there, but it is surprising how much is in Psych. So you can search for abstract concepts like circle. And there's several different things that you could mean by circle. Here's one of them. There's all sorts of stuff in here about what a circle is and what it's a subset of. This collection of circles is a subset of oval shapes and so on and so forth. You can look for everyday concepts like a shoe. Here's some stuff about shoes. Various things about how it relates to clothing and people and so on and so forth. You can look for relationships. So if you search on inside, you find this. And that tells you all sorts of things about it being an underspecified position predicate. So there's this very rich, complex hierarchy of concepts and relationships. If we go into underspecified propositional predicate, we get to, there we go. We get this, and which is just sort of a fairly abstract bookkeeping collection. If you then try and find all the other things that are underspecified position predicates, you get this. So in Psych, you have language to talk about things being through, among, inside, about, without, against, before, so on and so forth. Let's try something more everyday. President. Well, we have a president of organization. And then you have President Fun, which enables you to talk about the president of any organization without having to create that concept first. There's a lot of things like this in Psych that give you shortcuts to talk about things without having to create them first. So here is the President of the United States. And you notice that on all the terms, or most of the terms we've had so far, there's been things like pretty string and pretty string canonical. There are relationships between the parts of the psych knowledge base and everyday knowledge, Wikipedia, WordNet, the Sumo ontology from W3C, and so on. So if you are in a domain where you're working with natural language or ontology, this stuff is likely to be useful to you. And there's Macintosh computers and activities like cooking food. And you could say, this is just one I cited, oh, does it have thrillers? In fact, it has quite a bit of information about thrillers as a genre, and comedies. And in fact, if you look at subtypes of comedies, it even has romantic comedies and comedy TV shows, comedy movies, fast, dark comedy. So, assuming psych has started up, I'd like to try to give you an idea of what it looks like. Psych wants to use about 4 gigs of RAM, and that's how much RAM I have in this laptop, so it's swapping, which is why it's a little slow. Yeah, it looks like it started up. So, maybe I'll come back to that at the end once it's finished swapping. Let me show you something else. I was just going to show you the web browser and let people shout random terms at me, and we'll see if they're in psych. A surprising number of them are. Let me show you something else. So given that we have this psych knowledge base, you can access it from JRuby. The API for it is Java, so you fire, and psych itself is written in Java, so when you download it from SourceForge, it'll run just about anywhere. If you want to run it on a Mac, I've got some minor changes you need to make to the launch script on my website. But you can fire up JRuby, and I had never used JRuby before. I was surprised how easy it was to use. You have to require 2 files. One's a Jakarta ORO thing, which uses for regular expressions, and then the OpenCyc file. Now we create a connection. By the way, I always thought this would be a better way of doing a live demo than actually doing a live demo that might fail. So we just create a connection to psych. Over in the background, Java things are spinning up, right? Now we can say, okay, well, give me the psych term for dog. And JRuby does an amazing job of making it very easy to just use Java files without any other work. I'll do that, and now what's the comment on dog? Okay. Get generals, that is what psych is dog is the collection of dogs. So generals is the collection of collections that it is a subset of, right? So it's an immediate subset of domesticated animal, canine animal, and canis genus. We can ask for get siblings, and the psych API is huge. There's all kinds of stuff that will very quickly answer all kinds of questions about the psych knowledge base. So that's what you get if you go up to those 3 collections and then back down again. And that's the entire generals hierarchy going up, all the things that dog is a subtype of. And if you're wanting to do natural language processing, you're probably using a command like this, get denotes of string. So what things in psych are known as dog, and you have dog and dog. So if you look at this, you begin to get a sense of how you might actually make use of this, which is if you're doing something where you're trying to process natural language and do a little bit better than just a thesaurus in terms of finding similes, this is a pretty good way of having a go at doing better search or doing better classifications. So you've got an asset database, you know, and you're trying to enable people to find assets using terms they might not have used when they were putting it in, things like that. So I think it's practical to consider trying to use this aspect of psych. And there's a great deal more to psych than I've shown you. It has this query capability. You can put facts into psych. But I think in these sort of activities, you might want to, if you're engaged in any of this stuff, you might like to grab OpenCyc and take a look at it. Psych is Cyclopedia. So if you are interested in exploring this further, psych.com is the website for cyclop, that is the company behind psych, openpsych.com, and there's a non-profit psychfoundation.org that has some links to interesting resources. There's all kinds of presentations and papers, and they've got some interesting demos up online. They've got one that they're going to have up soon, I believe, where they take Wikipedia and give you a new way of accessing the content in Wikipedia. So if you're looking at an article on dog, say, it can use the psych hierarchy to suggest conceptually related concepts to dog that aren't mentioned anywhere in the article. It's actually really quite neat. And they've got a few other interesting things. They've got a browser up there which you can just go to online and look at the contents of psych without having to download any of the software, stuff like that. Any questions? I don't work for Cyclop, so I don't know if it is. They were trying to do some of that and starting to do some of that a few years ago when I was working there. I think in time it's at the point where there's enough stuff in it that I think people will start to do stuff with it. It's still hard. You're pushing the envelope with this stuff. Although I think making use of the ontology to do smarter classification and smarter searching and so on is an opportunity, actually, for people if they're working in the right domain.
Kind of a general question. It was 1984 that was declared the beginning of the AI winter, or in
Yes.
it. Is it still generally considered? Do you know? Are we still in AI winter? Or
That's an interesting question. When I was researching that online, and a lot of I think that people think that it is, and that AI was a waste of time and went nowhere. But in fact, AI is all around us. I think AI is a bad term. I think it should be more like simulated intelligence, because no one's got real artificial intelligence. Psych is the closest thing we have, I think. But there's all around us. There's software that does handwriting recognition and speech recognition and text recognition, and it's part of the zeitgeist now. There's particularly stuff that's running on like iPhones now. That's doing locations and activities and smushing them all together. I think that's really the godchild of the original AI research, if it's not AI itself.
I get the impression that lots of pieces have been solved to some degree.
Lots of useful stuff was developed. As I say, I don't think much of it is actually artificial intelligence. That's the hardest thing humans have ever tried to do, I think.
Now, there's a guy in the news just a few days ago who declared they're building something to simulate a human brain, and within 8 years or something.
Yeah, I wish him luck.
Yeah, lots of luck. That's.
But this project's been going like 25 years. Maybe in another 25 years we'll be getting close. I don't know. But it's interesting to have to play with, and it's maybe useful already.
First question is, how easy is it to extend? Because there's other ontologies like the biology,
Yes.
OWL. that you could extend things with?
Here we go. There are oh, that's gone down there. I don't know why. Okay, there, here's the psych browser. And I don't know, let's see if we can come up with a term that might have some kind of, blood. So there are already in Psych a lot of connections to outside sources of knowledge. There's connections to relevant Wikipedia articles fairly often. There's connections to, I think it has Sumo, you know, the standard upper merged ontology. So let's see, it's red, sanguinist, blood. So there's DBpedia link. There's W3 Synset link. You'll find you know, Wikipedia article.
Yeah, I thought I saw an OWL reference earlier.
There should be. You can also get an OWL version of the psych ontology.
Because if you put in something like intron or something that's more biology based.
Intron?
Intron.
So there is a bit of a mismatch between psych and other molecular segments that we're looking for. And other ontologies in that psych uses, a technical term would be something like arbitrary order predicate calculus. So there are a lot of things that are written in psych in a way that you just can't express in a lot of other ontologies. Nevertheless, most of it you certainly can. Polyonucleotide component type.
And the other question was, is this available as any sort of REST service or, you know, what you'd really like? For those of us with less than 4 gigs.
There is a service where you can search for a concept and it will give you back a canonical URL for it that represents that concept and will forever. But, you know, it wouldn't be hard to throw up a service using Ruby based on the psych API that's in Java. The sort of introspection capabilities of Ruby would mean it wouldn't be hard at all to throw up something that lets you just sort of hit a URL and it convert that string to a method call on the thing. The Psych Foundation is doing some stuff like that. If you're interested, you might like to contact them. And I think they have an API server that you can run, but it's just not released to the public yet because it's not finished. But you might be able to get hold of that and help them with it. You said you had 2 questions, or was that?
That was the second one, the one about services.
Anybody want to try and stump Psych and see if there's a concept that ought to reasonably be in it, or are we done? UCSD. No. Blood was in there, though. Sorry? Grok? That's a little obscure. You know, it's concepts, not words. So if I had understand, I'm sure that would probably be in there. Yes. So we have a representation of comprehending, it's just we don't have the relationship to that particular word. But you do have connections to, generally to WordNet, which you'd be able to use to find these things. What is kinase?
It's a type of drug target for pharmaceuticals.
Yeah, it's a type of enzyme.
Well, we probably have the concept of drug target, but not that specific one. It doesn't have a lot of very specific knowledge in any domain. It's intended to be a more sort of general purpose thing you can fit stuff under.
This whole ontology called gene ontology, I'm surprised that they don't, like, they could just somehow maybe suck it in, or maybe it would be compatible.
I'm not 100% sure. I think, though, if you have that available as an OWL ontology, you could just import it. So it's got very kind of interesting. It's the hardest part of this project of all is not developing the ontology. It's developing the inference engine that can do the reasoning with the ontology. The search space is absolutely ridiculous, and it's necessarily incomplete. Nevertheless, the search engine is the inference engine is an interesting thing to play with. You could even, depending on what sort of project you're doing, possibly use this as part of the as a kind of knowledge or data store for an application. I could imagine if you were developing a game or something, it would be interesting to sort of represent the stuff about the game in psych and then use that to generate the code. That would actually be a very, very flexible, a very fast way of doing a complex, rich world. Okay.
What is the inference engine? I guess maybe you don't know how many of this to show, but what does it do? Do you converse with it, or what is it?
You go here to query. Is that query? I think that's query. Yes. And then you can pose you give it a sentence in formal logic with variables, and it finds the variables that satisfy the query. It's a bit like using Prolog. It's very, very powerful, but slow because it's got this ridiculous search space every time you ask it something. The knowledge base is broken up into what are called micro theories, so you can have contradictory information in there that's true in this part of the knowledge base, but not over here. That's how it represents fictional worlds and things like that. So, if you're working in a limited domain, you can put all the stuff in a micro theory, and then the search is reasonably fast. Like I say, there's so much to this that I just haven't had a chance to show you yet. What I am planning on doing is putting together a couple of demos of using psych with Ruby to do some classifying documents and things like that. Maybe I'll come back and show you those in a few months. Try and convince you it may actually be useful for something. Okay. Thank you for your time.